We had the opportunity to actually fly down to Florida twice. We go ahead and walk out down the ramp, and this is the time we actually go launch. It was just an outstanding day. We were all set and ready to go. Down there in the bottom corner in the white suit, we've got astronaut John Harrington along with Carlos Gillis, who helped strap us in. We're out there on the pad, and everything is go. We just had the slight delays that you heard when given the awards. Then they said go ahead and launch. Of course, we light up the main engine 6 seconds prior to launch, and that's because we want to check the thousands of parameters. If anything's wrong, we can shut those down. We get the rock that we can definitely feel, and then there come the solids. And I know a lot of you have heard this before, but when the solids light, you really know that something significant in your life has happened. You're just not sure if it's good or not. It was a gorgeous day.
You can see the tip plate here starting out and the mast coming with it. The mast is going to be 200 feet long when fully extended, the largest rigid structure ever in space up to this time, and it all folds down into a 6-foot package. So it's a very clever mechanical design that allows that all to happen so smoothly, and you see how well it comes out here. This is the X-band panels and the C-band panels on the outboard antenna that will be at the end of the 200-foot mast. You see a graphic here showing that process. Here's the outboard antenna that's going to have to be flipped over to do mapping. And you can see how impressive that total structure is. The mast triples the moment of inertia of the shuttle when it's hanging that far outboard. After we get the whole 200 feet out, the base plate locks in place, and we now have a rigid structure that allows us to do the mapping as required. You see the view out the commander's window of the mast with the antenna in place and ready to start the next activity, which is flipping that antenna over so the receiving face will point at the Earth. Then we can maneuver it to the 45-degree angle to the horizon that's required for mapping. As Janet mentioned, the main beam in the bay is a radiator, and both the outboard and the center receive the signal. The X-band can actually track trees. The C-band is a longer wavelength than just as land. This shows you how the map was produced. Because the Earth turns underneath the shuttle as it rotates, the subsequent paths are 23 degrees apart. So it was a very challenging task for the folks that got the award earlier this evening to make sure that each